Welcome back to LittleAIMaster, where we don't just use AI, we raise one. Today is a deep dive into the single most magical sentence in tech. The AI learned it. We're going to open the box and watch, step by step, how a neural network actually learns. When grown-ups say an AI learned to spot a cat, here's the wild part. Nobody programmed the answer in. No human wrote cats have pointy ears, line 412. The AI figured it out from examples, the same messy way you learn to recognize your friend's face in a crowd. And the secret is almost insultingly simple. Learning, for you and for an AI, is one loop. Guess, get it wrong, fix the mistake, try again. Do that loop millions of times and you get something that can unlock your phone with your face. Let's build that loop from scratch. Start with the original learning machine, your brain. Right now, it's running on about 86 billion neurons. That's more brain cells than there are people on Earth, and each one connects to thousands of others, making more connections than there are stars in the Milky Way. Scientists peeked at one real neuron and copied it. A neuron has dendrites, little antennas catching signals from other neurons, a cell body that adds those signals up, and a threshold. If the total is strong enough, it fires. If not, it stays quiet. And the famous rule, neurons that fire together, wire together. Bite here. When you practice guitar, your brain literally strengthens the connections you use most and lets unused ones fade. That's Hebbian learning, named after Donald Hebb. Practice equals stronger connections. Hold on to that idea, because an artificial neuron learns by changing connection strengths too. Quick reality check before we worship the machine. Your whole brain runs on about 20 watts, roughly a dim light bulb. Training a big AI model can need GPUs pulling 300 watts or more. Biology is still the most efficient learner on the planet. Machines just go faster per step. If watching AI get demystified piece by piece is your thing, subscribe, because everything today is hands-on inside the LittleAIMaster app, where kids don't just learn AI, they raise one. Now, let's turn that brain cell into math. In 1943, McCulloch and Pitts turned the neuron into a formula, and it became the seed of all modern AI. An artificial neuron has 4 parts. Inputs, the numbers coming in. Weights, how much each input matters, a bias, how easily it fires, and an activation, the final yes or no decision. Here is the entire artificial neuron. Multiply each input by its weight, add them all up plus the bias, then run that sum through an activation. In symbols, z equals w1 x1 plus w2 x2, and so on, plus b, that's it. Everything AI does is built from this tiny machine. Inside the app, this isn't a diagram in a textbook, it's a neural network you can poke. Drag a weight up and watch a neuron light brighter, pull it down and watch it go dark. Seeing the signal flow is the moment weighted sum stops being scary words and becomes something obvious. Let's make it real. A single neuron can catch spam. Its inputs: number of caps, number of exclamation marks, money words, suspicious links. The email, you are a winner, free prize scores plus 7.2, flagged spam. Meeting tomorrow at 3 p.m. scores minus 2.5, safe. One neuron, learned weights, real decision. Now scale it up. Everything a network knows lives in just 2 things, weights and biases. GPT-3, 175 billion of them. That's all it knows, stored as numbers. Storing those weights alone takes about 700 gigabytes, more than most laptops hold. Think of weights as volume knobs on a sound mixer. A big positive weight turns an input up, it really matters. A negative weight turns it down, it pushes the answer the other way. A weight of 0, the neuron completely ignores that input. Learning is just finding the right knob settings. Picture a neuron recommending movies. Action weight plus 0.8, it loves action. Romance weight minus 0.1, mildly dislikes it. Feed in an action movie you rated 9 and the score rockets to 7.9. Same neuron, a romance film, scores 3.2. The weights are the AI's personal taste. Bite again. If weights are how much to listen, the bias is the neuron's mood. A positive bias makes it optimistic, quick to fire. A negative bias makes it skeptical, hard to convince. Spam filters use a negative bias on purpose, better to let a little spam through than block your grandma's email. So the whole game is finding good weights and biases. But here's the puzzle, and pause to guess in the comments. With billions of knobs, how could a machine possibly find the right settings? Trying every combination is impossible. Stick around, because the answer is genius. First, let's make the AI take a guess. When you show the network a picture, the numbers flow forward, layer by layer, transforming each step. This is forward propagation. For a handwritten digit, 784 pixel numbers go in, ripple through hidden layers, and it's a 7 comes out. Each layer rewrites the data into something a little smarter. Here's a trap. Without activations, 10 layers collapse into one, because adding and multiplying lines just makes another line. You can only draw straight cuts, you could never learn a circle or even XOR. The activation adds a bend, the nonlinear magic that lets networks learn curves and complex shapes. The most popular activation is hilariously simple, RayLU. If the number is positive, pass it through. If it's negative, output 0. That's the whole thing, max of 0 and Z. This one bent line helped power the entire deep learning revolution. Sometimes the simplest idea wins. Let's trace a tiny one. Inputs 1.0 and 2.0 say study hours and sleep hours. They get multiplied by weights, summed, relued, then a final neuron squashes the result with a sigmoid into 0.89. Out pops a prediction, 89% sure. The network just guessed. Now, was it any good? To improve, the AI needs a report card, and that's the loss function. It measures exactly how wrong a prediction is. Perfect guess, loss is 0. Small miss, small loss. Big miss, high loss. Low loss equals good student. The entire goal of learning is one thing, make the loss as small as possible. One common report card is mean squared error. Predict prices of 48, 63, 68 when the truth is 50, 60, 70, and your errors are 2, minus 3, 2. Square them so they can't cancel out, average them, you get 5.67. Squaring punishes big mistakes hard. An error of 10 becomes 100. Bite here with my favorite trick. For classifiers, we use cross-entropy, and it uses a logarithm to punish predictions that are confident and wrong. Being 99% sure something's safe when it's actually spam? Huge penalty. The loss isn't just a scoreboard, a number can teach the network which mistakes matter most. In the app's Train Your AI lab, you don't just hear about loss, you watch the curve fall. Every round of practice, the line drops a little. When that graph slopes down toward the bottom, you're literally watching your AI get less wrong. That dropping line is learning, made visible. If loss just clicked for you, smash like, it tells more curious families this exists. So now the AI can guess and score how wrong it is. The last piece is the genius part, using that score to fix the weights. Enter the mountain. Imagine you're blindfolded on a mountain and need to reach the valley. What do? You feel which way the ground slopes and step downhill. That's it. That's gradient descent, the algorithm that trains every neural network on Earth, an idea from way back in 1847. Why feel around instead of testing every weight? Because even 100 weights with 10 settings each gives 10 to the 100th combinations, more than there are atoms in the universe. You could never try them all. So we feel the slope of the loss and take one smart step toward lower error. Here's the most important formula in deep learning, and it's tiny. New weight equals old weight minus the learning rate times the gradient. The gradient points uphill toward more error, so we subtract it to go downhill. Repeat that small move, and the loss drifts toward the valley. That learning rate, the step size, is everything. Too tiny and training takes forever, baby steps down a mountain. Too big and you leap clean over the valley, land on the far slope, leap back and bounce forever without settling. Get it way wrong and the loss explodes to infinity. Goldilocks rules apply. Byte's favorite fact. This same tiny rule, weight minus step times slope, trains a toy model and a system with billions of weights. The whole trick is repeating good small moves millions of times. In practice, we use mini batches, around 32 to 128 examples per step, and an optimizer called Atom to keep it smooth. But wait, gradient descent needs to know which way is downhill for every single weight. With a million weights, how do you figure out which ones caused the error? It's like a recipe with a million ingredients tasting wrong and asking which one ruined it. That's the hardest question in AI. The answer is backpropagation, the most important algorithm in deep learning. After the guess flows forward, the error flows backward, like rewinding a movie. Layer by layer, it assigns blame, telling each weight exactly how much it contributed to the mistake, and therefore how much to nudge it. Its secret weapon is the chain rule from calculus, breaking a big tangled function into simple steps and multiplying the slopes. The brilliance: one backward sweep computes the blame for every weight at once, reusing earlier work instead of redoing it. A million gradients, almost as fast as a single forward pass. Make it concrete. A tiny network predicts 0.63 when the target is 2. Backprop traces the blame and finds the gradient on weight 1 is minus 0.485. Negative means turn that knob up to reduce the error. The math literally hands you the direction to fix every single weight. And that completes the circle. Forward to guess, loss to score, backprop to assign blame, gradient descent to adjust. Round and round. If your brain is buzzing, comment the one idea that surprised you most. Now let's zoom out and see the whole loop in one breath. Meet Dia, a real example from our course. Her grandma shows her a small brown bird. That's a sparrow. Next day, Dia guesses, gets confirmed, and improves. Input, process, output, feedback, adjust. That's the learning loop, and an AI runs the exact same circle, just millions of times faster. For a cat versus dog AI, the loop is: feed in thousands of labeled photos, find patterns like pointy ears and whiskers, guess on a new photo, then check against the true label and adjust the weights. Wild detail: it never sees pictures, only numbers, pixel values, it hunts patterns inside. This is the heart of LittleAIMaster. You don't watch a finished AI, you raise one. You name your model, feed it examples, watch its accuracy climb, and it grows with you across the whole course. Guess, feedback, adjust, the loop you just learned, with your hands on the controls. And here's the payoff. The same 5 ideas, neurons, weights, forward guess, loss, and gradient descent with backprop, power everything. Face unlock, Netflix recommendations, even ChatGPT with its 175 billion weights. They're not magic. They're this loop, scaled up and repeated an unimaginable number of times. Ready to go further? In the Python lab, older kids write the actual training loop in real code. The same forward loss backward steps, no scary setup, running right in the app. The ideas you just met become lines you type and run yourself. That's where understanding turns into building. Let's lock it in. 1. A neuron multiplies inputs by weights, adds a bias, and decides. 2. Weights are the memory. 3. Forward propagation makes a guess. 4. Loss scores how wrong it is. 5. Gradient descent plus backprop fixes every weight. Guess, score, blame, adjust, repeat. Bytes parting thought. One correction looks tiny, almost pointless. But repeated across thousands and millions of loops, those tiny adjustments turn random guesses into something that beats grandmasters at chess. Learning, for brains and machines, grows from tiny adjustments that never stop. That's the whole secret. When a young learner finishes a chapter in the app, they don't just nod along, they earn a certificate that proves they get how AI actually learns. It's the difference between watching a video and truly understanding the machine, quietly running your whole digital world. That's how a neural network actually learns. Guess, get it wrong, feel the slope, fix the weights, repeat. The rest of AI is just this, bigger. If your kid wants to stop using AI and start raising one, the whole journey is free to begin at LittleAIMaster.com. Subscribe so you never miss the next deep dive, drop a comment with what you want us to open up next, and go play with a real neural network in the app. Remember the motto, don't just use AI, raise one. See you in the next one.